All right, so we're doing a titration, right? We've got this base up here in our burette. You can tell it's got this little stopcock, which allows us to well control the amount of base added, and we know that concentration of the base. And then in here in our Erlenmeyer flask, we have the acid, which is an unknown concentration. And then we start adding the liquid. After a while, we'll start seeing a little pink stay, but then disappear. That means that you're getting pretty close to the endpoint. And your goal is to get to this light pink color. That's the endpoint. If you go to a dark pink color, then you've overshot the titration. So let's take a look at data from an example, and let's calculate the concentration of our unknown acid. So our question is going to go like this. So a titration of 10.00 mLs of an HCl solution requires 14.53 ml of 0.125 molar NaOH to reach the equivalence point, which is our ending point, when our solution turns a light pink. What is the concentration of the HCl? And this is generally given in molarity. So let's think about what our question is asking. It's asking us for the molarity of the concentration. So think about what molarity of the HCl concentration is going to be. It's going to be the moles of the solute, which in this case is the HCl, divided by the liters of the solution. So let's think about what values we have and what values we can use here. So we can see that we're titrating 10 mLs of the HCl. So we have how much solution we have, right? That's given to us in the problem. So we have 10.00 ml of our solution, but remember this is in liters, so we need to convert from milliliters to liters. So there's 1,000 ml in 1 liter. So there's our liters of solution. And so we can take this number right here and plug it into the denominator where liters of solution goes. Next up, we have to solve for our moles of HCl. Again, this isn't really anything new. This is just stoichiometry, right? So how many moles of HCl do we have using the data given to us? So remember, where you generally want to start off with is the thing that's not a conversion unit. So if we look at what's not a conversion unit, it's just this amount of NaOH. So we can start off there. So we have 14.53 mLs of NaOH. If we think about what other data we have the concentration of the NaOH. So that's in molarity. So that would be equal to 0.125 moles of NaOH over 1 liter of solution. And so we can see that the denominator is liters. Here we've got milliliters. Those are both volumes. So we can get them to interconvert with one another. But first we have to change this to liters. 1,000 ml, 1 L up here, that then becomes liters. And now that it's liters, we can then use our molarity concentration to cancel some more units out and continue our conversion. So here we would have 0.125 moles. And then down here, we would have 1 liter. And so then the liters and liters would cancel out. Now we're at moles of NaOH, but think about what our question is asking. We want the molarity of the HCl, not the NaOH. So how do we go from moles of one component to moles of another component? To do that, we need to take a look at our equation. In this case, our equation is HCl plus NaOH, forming water and NaCl. It's a neutralization reaction, right? We've learned about that. And if we look at our coefficients, they're both 1. So in this case, there's just 1 NaOH will give you 1 HCl. So not too bad there. It's a 1-to-1 conversion. And then now we're at moles of HCl, which is where we wanted to be. So we can go ahead, plug and chug through our calculator. We should get 0.0018 0.163 moles of HCl. And then we simply take this value and plug it up top for our moles of HCl, divided by the liters of solution, and then you should get 0.182 molar HCl. So again, nothing really new there, just some conversion problems using our units of concentration. And then really the best way, as always, to get good at this is to do some practice.